Hello, welcome to Philos Academy. In today's tutorial, I'm going to take you through confidence interval for mean for a large sample or a known population standard deviation. This is a symbol we use to represent population standard deviation. Okay, so all what we'll be looking at in this particular video is about a large sample or when the population standard deviation is known. So now let's look at the meaning of confidence interval. Now when we talk about confidence interval, it is a range of values constructed from sample data so that the population parameter is likely to occur within that range at a specified probability. Now that specified probability is called the level of confidence. Now before we go further, there's something very important I want you to know, and that is measures and the various symbols we use to represent them. Now for the sample mean, the symbol we use to represent the sample mean is X bar, and then for the sample variance, the symbol is small s square, and then for sample standard deviation, we use a small s without a square to represent it. But when we talk about population, for population mean, we use mu to represent it, okay, and then for population variance, we use sigma square. This is called sigma, then you add square to it. So sigma square is a symbol for population variance, and then sigma without a square is a symbol for population standard deviation. So now let's look at the formula we're going to use in this topic. So the formula we're going to use in this topic is X bar minus z multiplying standard deviation over root n less than mu less than X bar plus z multiplying standard deviation over root n. Now this same formula, you can write it as X bar plus or minus z multiplying standard deviation over root n. The reason is the X bar here is the same as what is here, and then z times standard deviation over root n here is the same as what is here. Just that here we subtract and here we add. Okay. Now the X bar represents the sample mean, and then this represents the standard deviation, and then the n represents the sample size. Okay. Same thing at this side also, and the mu represents the population mean. And also for the z is just the critical value. Okay, that is, we use the level of confidence to determine what the z will be by checking the z table. Okay, now the standard deviation divided by root n is called standard error. Okay, and then the entire z times standard deviation over root n, we call it margin of error, and we represent it with e. Okay, margin of error. I mean the entire z times standard deviation over root n, we call it margin of error. It is the greatest possible distance between the point estimate, that is the sample mean, and the value of the parameter it is estimated, that is the population mean. So the greatest possible distance between the population mean and the sample mean is the margin of error. Okay, this is also a margin of error, z times standard deviation over root n. We call it margin of error. Another name for it is maximum error of estimate or error tolerance. Okay, that's another name for it. Now, I told you that whenever you have a question, it says the level of confidence given in the question that will determine what your z will be, isn't it? But there are some level of confidence that are very common in every question. So I'm going to give you those level of confidence and then tell you their z scores. Then you make sure you keep them. Okay. Now, whenever a question gives you level of confidence to be 90%, okay, then your z should be 1.645 or 1.65. And then whenever a question gives you a level of confidence to be 95%, then the z score should be 1.96. Also, whenever a question gives you level of confidence to be 98%, then the z score should be 2.33. And then when a question gives you level of confidence of 99%, the z score should be 2.575. Okay. A question can give you 80% and others. but these four are more common, okay? So it's good you keep their z-scores. And then this 1.645, you can approximate it to 1.65, okay? And then this 2.575, you can approximate it to 2.58. So let's take a practical example, then you understand this better. Example 1 says, a sample of 81 observations is taken from a normal population. The sample mean is 40 and the sample standard deviation is 5. Determine the 95% confidence interval for the population mean. Now, it is not every question that you see that you use Z for, okay? There are some questions that you can't use Z for it. You have to use T in place of Z. You use T. And how do you know that type of question? Now, I want you to know that in this video, everything we'll be looking at is about a Z. In the next video, we will look at how questions on T looks like, okay? Now, let's go back to the question. For you to use Z, your question must meet either of the conditions I stated at the beginning of the video. That is, the sample should be what? A large sample. Or the population standard deviation should be known. When we say large sample, it means that the sample size is greater than or equal to 30. If the sample size is less than 30, then it is a small sample. But if the sample size is greater than 30 or equal to 30, then it is a large sample. Okay. So whenever you have a question, and then the sample size is more than or equal to 30, whether or not the population standard deviation is known, you should use the Z. Okay. Also, if you have a sample size to be less than 30, and the population standard deviation is known, you still use Z because you were able to meet one of the two conditions. The thing is, you should be able to meet one of the two. If there is any case where you fail to meet either of the two conditions, then you are going to use T. So let's solve this together. Now, according to the question, the sample size is 81, so our N is 81. And then when you read further, it says the sample mean is 40. So it means that X bar is equal to 40. And the sample standard deviation is 5. So S, small s is equal to 5. Okay. But because the sample size is more than 30, we approximate the sample standard deviation to be a population 1. And then the question also says, determine the 95% confidence. I told you earlier that whenever a question gives you 95% confidence, you should take the z-score to be 1.96. So our z is 1.96. So now, let's recall the formula for confidence interval. The formula for confidence interval says that X bar minus Z times standard deviation over root N less than mu less than X bar plus Z times standard deviation over root N. Since we have our N, we have our X bar, and then we have our standard deviation and also the Z score, then we substitute into the formula. So when we substitute, we're going to have 40 as our X bar minus our Z is 1.96, isn't it? Then times, there should be a multiplication here, okay? So times standard deviation, which is 5, divided by square root of N, and our N is 81, so we substitute 81 here, less than mu, less than, now everything you've written here, you repeat same thing at the other side here, but this time around, it should be a plus, okay? This place is a minus, and this place is a plus, that's the difference. So, you have 40 minus, when you put 1.96 times 5 over root 81 on your calculator, you get 1.0889, okay? And then at this side too is the same. So that will be 40 minus 1.0889. And at this side too, you have 40 plus 1.0889. So 40 minus 1.0889 will give us 38.9111, and then 40 plus 1.0889 will give us 41.0889. Now you can leave your answer like this, or you approximate it to 2 decimal places. So in 2 decimal places, our answer will be 38.91, and this side will be 41.09. Now, make sure that when you leave the lower limit in 2 decimal places, make sure the upper limit is also in 2 decimal places. When you leave the lower limit in 3 decimal places, make sure the upper limit is also in 3 decimal places. So I have decided to leave mine in 2 decimal places. That is 38.91 and 41.09. You can also leave it 38.9 and this one will be 41.1. Okay. So after getting the final answer, you can conclude that one can be 95% confident that the population mean will be between 38.91 and 41.09. Also, you can use the second formula, which says x bar plus or minus z times standard deviation over root n. So when you substitute into this, you have 40 plus or minus, our z was 1.96, isn't it? And our standard deviation is 5. Then divided by square root of 81 because our n was 81. So when you use your calculator to compute 1.96 times 5 over root 81, you get 1.0889. So you have 40 plus or minus 1.0889. So when you get to this stage, then you take separately 40 minus 1.0889. You get 38.9111. And then you also take 40 plus 1.0889 separately. And then you get 41.0889. So you can leave your answers in 2 decimal places, as in 38.91, and this will be 41.09. So you can write your answer in this form here, or you write it in this form, 38.91, 41.09. You can choose to write your answer in this form, 38.91 less than mu less than 41.09, or you can also choose to leave your answer in bracket this way. Okay, but what matters is the interpretation. The one can be 95% confident that the population mean will be between 38.91 and 41.09. Now, before I go to the next example, remember, the reason I use Z for this and not T is that the sample size is greater than or equal to 30, even though the population standard deviation was not known. But still, since the sample size is more than or equal to 30, then you can still use the Z. So let's look at example 2. Example 2 says, a sample of 10 observations is selected from a normal population, for which the population standard deviation is known to be 5. The sample mean is 20. Determine the 95% confidence interval for the mean. So to solve this question, now look at something. You see that the sample size here is 10, which is a small sample. So when you first read this question, you will think that you can use the Z, isn't it? But when you read the question further, you realize that they said the population standard deviation is known to be 5. Even though the question didn't meet the first condition that n should be greater than or equal to 30. But since the question has been able to meet the condition that the population standard deviation should be known, okay, then you can still use the Z. You can only use the T if the question failed to meet the 2 conditions. But if the question meets one of the 2 conditions, you still use the Z. So to solve this, our sample size is 10, so meaning our n is 10. And then according to the question, the population standard deviation is 5. And then the sample mean is 20, so x bar is equal to 20. But the question says, determine the 95% confidence interval for the mean. Remember, whenever a question gives you 95%, the z-score is 1.96. So this is what we are going to use to find the confidence interval. So what's the formula for the confidence interval? It is x bar minus z multiplying standard deviation over root n less than mu less than x bar plus z multiplying standard deviation over root n. So let's substitute them into the formula. So we're going to have 20 minus 1.96 times 5 over root 10. That is our x bar was 20, so when you place it there, you have 20 minus the z-score was 1.96, so we substitute 1.96 in place of the z, okay, and then the population standard deviation was 5, so in place of the sigma, we're going to place 5 there, and then the n is 10, so we're going to have root 10, okay, less than mu. Now everything you've written here, you repeat the same thing at the other side, but here should be a plus, and this side should be minus. Now, when you take your calculator and you check 1.96 times 5 over root 10, you will get 3.009. So, you are going to have 20 minus 3.009 at the left, and then at the right, you have 20 plus 3.009. So, when you take your calculator and you check 20 minus 3.009, you should get 16.901. And then 20 plus 3.009 will give you 23.099. You can leave your answer in 2 decimal places or 1 decimal place. So in 1 decimal place, the answer will be 16.9 and this one will be 23.1. Okay. Now take note of something. If you add the lower limit and the upper and then you divide it by 2, you get your mean back. Try it and see. 16.9 plus 23.1 divided by 2, it will give you 20. You must get the mean back. Okay, so this is the final answer to this. Now you can choose to use the other way, that is x bar plus or minus z times standard deviation over root n. This formula is still the same as this, just that this is trying to avoid repetition. That's why we use plus or minus. Okay, so let's substitute into this. We're going to have 20 plus or minus, our z is 1.96, isn't it? And the standard deviation is 5 divided by root 10. Okay, our sample size is 10. Now 1.96 times 5 over root 10 should give you 3.099, isn't it? So we will have 20 plus or minus 3.099. So first you take 20 minus 3.099 and that will give you 16.901. And then separately, you also find 20 plus 3.099 and this will also give you 23.099. You can approximate them to 1 decimal place. So the answer will be 16.9, 23.1. You can decide to write your answer in this form or in this form. What matters is the interpretation. So you can conclude that, hence, one can be 95% confident that the population mean will be between 16.9 and 23.1. So that is the final answer to this. So let's go to the next subtopic. So now let's look at how to find a z-score when given a confidence level. Now before we take example 1 and example 2, I gave you something like this, that whenever a question gives you 90% confidence, the z-score is 1.645, 95% is 1.96, 98% is 2.33, and then 99% is 2.575. Now, what about if a question gives you 85% or 80%? How will you find it yourself? So that's what we are interested in this subtopic. But I'm going to use the same 90%, 95%, 98%, and 99% to show you how to find it. So that whenever you have 85%, 80%, and any other percent, you can find it yourself. So let's take the 90% confidence level first. So to do that, you are going to use the z-table. The z-table at the left is a positive full z-table, and then the one at the right is a half z-table. Now in our previous video, that is normal distribution, I taught you how to read this z-table and this. And I also said that this half z-table is mostly used by continuing students, and then the full one is mostly used by first years. But it is good you know the two of them, okay? But let's see how we are going to get the various z-scores for 90%, 95%, 98%, and 99% on the z-table. To do that, keep this formula: 1 plus c divided by 2, and also keep c divided by 2. If you are using a full z-table, then keep this formula. If you are using a half z-table, keep this formula. Now this is how we are going to use it. Now C represents the confidence level in decimal form. Okay. Now let's find a z-score for 90%. So 90% in decimal is 0.9. So when you fix it in the formula, you have 1 plus 0.9 divided by 2. And 1 plus 0.9 will give you 1.9. When you divide it by 2, you get 0.95. Leave it in 4 decimal places. So that will be 0.9500. So let's go to the full table. Remember, I said you should keep this if you are using a full Z table. So let's go to the full Z table. 0.9500. We are going to look for it at the middle here. Okay, and look for the z-score that corresponds to it. So let's look for 9500. Now when you look through the entire middle here, in an attempt to get 0.9500, you end up getting these two values. You have 0.9495, and here too you have 0.9505. You realize that your 0.9500 is between the two values, isn't it? So the best thing you can do for this type of situation is that you take the z-score of 0.9495 and also take the z-score of 0.9505. When you take their various z-scores, add them together and divide by 2. That is finding the average z-score. So what is the z-score of 0.9495? It will be 1.6. When you trace it up, is 4, so it is 1.64. And then the z-score of 0.9505 is 1.65. So quickly check 1.64 plus 1.65 all divided by 2. You get 1.645. So that is why the z-score is 1.645. You can approximate it to 2 decimal places, and that will be 1.65. In case you are using a half Z table, you just use C over 2. Your C is 0.9. So 0.9 divided by 2 will give you 0.45. So you leave that one too in 4 decimal places. Then you go and check the half table. So you look for 0.4500 at the middle. So let's look for 4500. Now here too we have 4495 and 4505. It means that 4500 is between 4495 and 4505, because 4505 is more than 4500 and this is below it, so it's between them. So to get a z-score that corresponds to 4500, you take the z-score of 4495, which is 1.64, as you can see, and then you take the z-score of this also, which is 1.65. Add them together and divide by 2, you get 1.645. You see that we get the same answer, even though we are using different Z tables. So let's try that for 95% also. When you convert 95% to decimals, you get 0.95. So fix 0.95 here. You have 1 plus 0.95, all divided by 2, and that will be 1.95 divided by 2, and that will give you 0.975. You can leave it in 4 decimal places, and that will be 0.9750. So let's go and check the Z table for 0.9750. So we are looking for 0.9750. 9750 at the middle. Okay. So this one we get it straight. 0.9750 is there. Okay. So you check its Z-score. So the Z-score is 1.9. So you trace it up also. So 1.96. So that is the answer. 95% is 1.96. You see that. If you are using a half table, then you just take 0.95 divided by 2, and that will give you 0.4750. So let's go and check it on the half table. So 0.4750, 0.4750, this is 4750. So let's check the z-score that it corresponds to. That's 1.9. So let's check it upward also. This is 6, so 1.96. So that is the answer to this also. Let's check it for 98%. 98% in decimal is 0.98, isn't it? So when we fix it here, we have 1 plus 0.98 divided by 2, and that will give us 0.99. In 4 decimal places is 0.9900. So let's look out for 0.9900 on the full table. So 0.9900. So we have here 0.9901, and we also have here 0.9898. So it means that 0.9900 is between them. Okay, so we'll take the z-score of this person, which is 2.32, and the z-score of this one is also 2.33. So check 2.32 plus 2.33 divided by 2. You get 2.325, isn't it? You can approximate that 2.325 to 2.33. Okay, or when you check the two of them, you realize that 0.9901 is more closer to 0.9900 than 0.9898. So because 0.9901 is more closer to it, you can just take the z-score of 0.9901 straightforward, and that is 2.33, which is the same as. So the z-score for 98% is 2.33. Now in case you are using a half table, you just take 0.98 divided by 2. 0.98 divided by 2 will give you 0.4900. So let's check 4900. So we look for 4900. So 4900. So we have 4901 here, which is very close to 4900. So its z-score is 2.3. Trace it up 3. So 2.33. So we get the same answer. So that is how to get a z-score. So you can try that for 80%, 85%, 87%, and the likes. Now let's look at how to find a minimum sample size to estimate a mean. Now remember, in the formula for confidence interval, I told you that the part where you have z times standard deviation over root n is called margin of error, and we use e to represent it. Given a C confidence level and a margin of error, that is E, the minimum sample size n needed to estimate the population mean is n equals z times standard deviation over margin of error all squared. In this topic, we want to look at how to find a minimum sample size. So this is the formula we are going to be using. This formula was derived from the formula for margin of error. Remember, I told you that margin of error, that is E, is equal to z times standard deviation over root n, isn't it? So let's make n the subject. Now to make n the subject, the LCM here is root n, isn't it? So let's multiply both sides by root n. So when we multiply both sides by root n, we have root n times E is equal to z times standard deviation over root n times root n. Now this root n will cancel out this root n. Root n times E will give you E root n. Multiplication is commutative. And then z times standard deviation, you still have z times standard deviation. But we want to make n the subject. So to make n the subject, we must do away with every other thing affecting n. Now when you look at this E is the coefficient of root n. So first, let's do away with the E. So to do away with the E, we divide both sides by what? By E. Now when we divide both sides by E, this E will cancel out this E. That is the main reason we are dividing both sides, so that we can get rid of this E at the left. So now we have root n equals z times standard deviation divided by E. Also, to do away with this square root, the best thing we can do is to square both sides. So when you square both sides, the square will cancel out the square root. Okay. Then you have n to be equal to, since you've squared both sides, this side will be affected by a square. So you have n to be equal to z times standard deviation over E all squared. So that's where we derive this formula here from. Okay. You can also write it n is equal to z squared times standard deviation squared divided by E squared. So let's take some questions on this. Example 1 says, a scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From a previous study, the standard deviation of the depth measured was 4.33 feet. Find the minimum sample size needed to estimate the mean. The question says, find the minimum sample size needed to estimate the mean. So to solve this, we recall the formula. The formula says n equals z times standard deviation over e all squared. Now it means that to get the value of n, we need the z score, we also need the standard deviation, we need the what? The margin of error. Now when you look at the question gave us 99% confidence. And remember, for 99% confidence under this topic, the z-score should be 2.58 or 2.575, isn't it? So meaning we know our z already to be 2.575 or 2.58. And then the standard deviation was also given as 4.33 because the question says the standard deviation of the depth measured was 4.33 feet. So this is the standard deviation. Now when you look at the question says he wants to be 99% confident that the estimate is accurate within 2 feet. Whenever you have a statement like this, within 2 feet, within 5 feet, you should know that this is the margin of error. Okay, so our margin of error is 2. So let's substitute that in the formula. So we are going to have what? So the z is 2.58 times the standard deviation is 4.33 and the margin of error is 2. So take your calculator and check 2.58 times 4.33 divided by 2. You get 5.5857, then square. Okay, so when you check 5.5857 square, you get 31.2. Now this is not the final answer, so whenever you get n in decimal, make sure you run the answer up. Okay, so you run the answer to 32. In this topic, it is a must for you to run it up. Okay, so that will be 32. So the minimum sample size needed to estimate the mean is 32. So that's the answer to this. So let's look at example 2. Example 2 says, a pizza shop owner wishes to find a 90% confidence interval of the true mean cost of a large plain pizza. How large should a sample be if she wishes to be accurate within $0.15? A previous study showed that the standard deviation of the price was $0.26. So to solve this, we recall the formula. The formula says n is equal to z times standard deviation over e all square, isn't it? Now, according to the question, for 90% confidence, remember the z-score is 1.645 or 1.65. And then the question says to be accurate within 0.15. So whenever you see a statement like this, you should know that is the margin of error. Okay. And then the question also gives us standard deviation of 0.26. So we just substitute it in the formula. So we have 1.645, which is the z-score, times standard deviation, which is 0.26, divided by the margin of error, which is 0.15, all squared. So when you check 1.645 times 0.26 divided by 0.15, you get 2.851, then square. So 2.851 square will give you 8.128. Now remember, you won't leave your answer in this form. You must run it up. So when you run 8.128 upward to the nearest whole number, you get 9. So the sample size required is what? Is 9. So let's look at one tricky question together. The question says, the 90% confidence interval for the mean one-way commuting time in New York City is 5.22 less than mu less than 5.98 minutes. Construct a 95% confidence interval based on the same data. Which intervals provide more information? What happened is that the question wants you to use the data that was used to estimate this confidence interval to construct a new confidence interval at 95% confidence level. So to solve this is what we're going to do. Now remember that you got the left by taking x bar minus z times standard deviation over root n, isn't it? And then you got 5.98 by using the formula x bar plus z times standard deviation over root n, isn't it? So say if that is the case, then the best way to go by this question is to say that x bar plus z times standard deviation over root n is equal to 5.98. That's 5.98. Remember that we got the upper limit by using the formula x bar plus z times standard deviation over root n. And then we got the lower limit by using the formula x bar minus z times standard deviation over root n. Just take this part, 5.98, and equate it to x bar plus z times standard deviation over root n. Now, after equating, you can also find the x bar by adding the lower and the upper and then dividing them by 2. So 5.22 plus 5.98 divided by 2, you get 5.6. So that is the sample mean. Also, after getting the 5.6, then you also find the z-score. Now, 90% confidence level was used to estimate this, isn't it? So, since it is 90%, we know that the z-score for 90% is 1.645 or 1.65, isn't it? So, since we know the z-score and then we know the x-bar, then we substitute it into this equation here. So, let's substitute. We have 5.6 plus, as z is 1.65, so 1.65 times standard deviation over root n equals 5.98. So let's group like them by bringing 5.6 to this side. So we have 1.65 times standard deviation over root n equals 5.98. Since positive 5.6 is crossing the equal to sign, it becomes negative, so minus 5.6. So we have 1.65 times standard deviation over root n equals 5.98 minus 5.6 will give you 0.38. So the next thing to do is to divide both sides by the coefficient of sigma over root n, which is 1.65. So when we divide both sides by 1.65, this 1.65 will cancel this 1.65. So we have sigma over root n equals 0.38 divided by 1.65. So 0.38 divided by 1.65 will give you 0.23. So sigma over root n is equal to 0.23. Now, after getting this, let's go back to the question. The question says, construct a 95% confidence interval based on the same data. Now, for 95% confidence, the z-score is 1.96, isn't it? But the question says we should use the same data from here to find the 95% confidence, isn't it? So it means that we should take the same mean and the same standard deviation over root n. So the mean is 5.6 and then the standard deviation over root n is 0.23. So what we're going to do is to recall the formula. The formula says x bar minus z times standard deviation over root n. And this side is x bar plus z times standard deviation over root n, isn't it? So let's substitute into it. So we have 5.6 minus, now our z-score here is 1.96, isn't it? And then standard deviation over root n, from the previous solution we got 0.23, so we substitute it there. So at this side we do the same thing, but this one will be a plus and this will be a minus. So when you check 1.96 times 0.23, you get 0.4508. So we're going to have 5.6 minus 0.4508 less than mu less than, then at this side we have 5.6 plus 0.4508. It's just repetition, just that here is positive and this side is negative. So 5.6 minus 0.4508 will give you 5.1492, and then 5.6 plus 0.4508 will give you 6.0508. So you can decide to leave your answer in 2 decimal places. So this in 2 decimal places will be 5.15 and this in 2 decimal places will be 6.05. Remember that if you leave this in 4 decimal places, make sure the other side is also in 4 decimal places. If you leave this in 2 decimal places, make sure the other side is also in 2 decimal places. So one can be 95% confident that the mean is between 5.15 and 6.05. But the question also asks which interval provides more information. So to know the one that provides more information, just check the difference between the upper and the lower of this one. 5.98 minus 5.22, you get 0.76. And then check that for this also, you get 0.9. So 0.9 is more than 0.76. But you use the same data, just that you use different confidence levels. Okay, so this particular one provides more information. So let's take another examinable question. A survey of 30 emergency room patients found that the average waiting time for treatment was 174.3 minutes. Assuming that the population standard deviation is 46.5 minutes, find the best point estimate of the population mean and the 99% confidence of the population mean. So to solve this, the first question asks that find the best point estimate of the population mean. Remember that the best point estimate of the population mean is the sample mean. So to answer the first question, you say the best point estimate of the population mean is 174.3 minutes. That is the average. Okay. You take the sample mean as the best point estimate of the population mean. So let's go to the second question. The second question says you should construct a 99% confidence interval. So to do that, let's recall the formula. I gave you two formulas for confidence interval and I told you that they are both the same. So you can decide to use either of them. Okay. So I want to write this x bar plus or minus z times standard deviation over root n. So according to the question, our x bar is 174.3. That's the sample mean. Our standard deviation is 46.5 minutes. And then the question gave us 99% confidence. So the z-score for 99% is 2.575 or 2.58. So we are going to substitute it in the formula. Also, remember that the reason we are using z and not t in this question is that the standard deviation is a population standard deviation. If the standard deviation were not a population standard deviation, since the sample size is a large sample, it also confirms that you can use z. Okay. Remember, large sample means that n is greater than or equal to 30, and when n is less than 30, it is a small sample. So to solve this, let's substitute into the formula. So we have 174.3 plus or minus, our z is 2.58, and then the standard deviation is 46.5, divided by roots, our n is 30. 2.58 times 46.5 divided by root 30 will give you 21.9. So we're going to have 174.3 plus or minus 21.9. So we'll take 174.3 minus 21.9 separately, and that will give us 152.4. When you also take 174.3 plus 21.9 also separately, you get 196.2. So the answer is 152.4, 196.2. So you conclude that one can be 99% confident that the population mean will be between 152.4 and 196.2. So our next topic is confidence interval for mean for small sample, and this is a typing mistake. It should be and. Okay. And unknown population standard deviation. It means that you must meet the two conditions together before you can use the t. So it means that in the next topic we are going to look at the t distribution. You can check the link for the next topic in the description area. And if you have not subscribed to the channel yet, do that now so that you can see the next topics easily. Thank you.